Okay, this is the 2-2 notes for statistics. We're going to look at other types of graphs and ways to organize our data so that when we're looking at our data, we can better understand what's going on. So the first type that we will look at is a stem and leaf. Stem is referring to the first number before the bar, and the leaf is referring to all the numbers after the bar. The leaves actually are like the ones place, and the stems are like the tens place. You know that by looking at your key. So sometimes the stem at that bar represents a decimal. Sometimes it represents a place, sticking a place value. So a way to display quantitative data graphically, in which every entry is separated into a stem and leaf. You have as many leaves as there are entries. So the numbers behind the bar, if you counted up how many there would be as many as you see actual data points. And the leaves indicate one specific data point. So I'm going to walk through this setup real briefly. So your first step is to look at your data points and see what is my smallest numbers to my biggest numbers. And we're going to do the unordered first, and then we'll reorder them after we've done that. So our smallest number here is 67. That's our min. And then we want to know what our max is, and that in this case was 95, I believe. Yeah, 95. So that's our max. So that tells us that we're looking at the 60s, 70s, 80s, and 90s. So that's what we're going to write out. I'm going to pull this page out so I can look at it. So 60s, 70s, 80s, and then 90s. Okay, so again, it's very important that we always know what our key is. So before you even start doing something, I recommend look at your key or write out a key. So I'm going to use 6 bar 7 to represent 67. And that tells us that each of the first numbers represents the tens place. Each of the numbers that I'm going to list afterward is the ones representing one single element in that. And basically you go through it and you do just like you did with the frequency table. So I see a 75, I'm going to write 75 down. Next, I see an 85, so I'm going to put an 85 down, okay? And you would continue that pattern very quickly going through, just jotting down each number and one. Now notice I'm not putting them in order here. I'm simply putting them down in the order that they happen to be showing up on here. And the reason this is really nice is because it gets your numbers in a kind of a organized grouping without doing a huge amount of, having to rewrite and going, okay, what would be the next number? Because it's basically organizing our numbers already. Now they aren't in numeric order yet. That's the last step. So we're just going to keep on going through that until we get all of our numbers done. And then once we have them all done, oops, and it's real important you tick them off as you go. That way you don't accidentally write one down twice. Now you could go through these and just grab all of the ones that are in the 80s, as long as you are ticking them off as you go. That's a really important step to it. Okay, so now I've got them all here. Now I'm going to rewrite them in ordered form. You're not completely correct until they're all in ordered form. So again, we start with our stems. Those would stay the same. And now we're going to take just the first ones and put those two numbers in numeric order. Well, lucky for us, they were already in numeric order. The next one, we're going to list these in numeric order. And if I see repeating numbers, I'm still going to write those repeating numbers. That means that I actually have two 75s in my data set. Okay, so there's a 73, there's a 75, a 75, a 76, and a 79. And the 80s, we had 0, 0, a 2, a 3, 2 5s, a 7, and an 8. Oops, I used the wrong color. You get the point. Okay, and the 90s, we had 0. This time we had 3 ones. And if you notice, I am kind of spacing my numbers out to try to help keep it from getting too crowded, especially because I don't want to think of these as 11. I want to think of them as a 0, a 1, a 1, a 1, 1. You don't put commas between them, but you do normally see them spaced out just a smidge. And again, this is my final version of it, so I still want to have my key. And I want to make sure that I have a title. So what does this represent? This is the scores for biology, or biology scores, something like that. Okay. Now, what pattern do you see? Now, here's where this comes in handy. So if I turn my paper and I'm just looking at my finished product, you can almost see a bar graph being born here. So there's 2, there's 1, 2, 3, 4, 5. This would have been a frequency of 5 in the 60s range. It would have been a bar graph of 2, because there's 62 frequencies in the 60s, 60 to 69. From 70 to 79, there's 1, 2, 3, 4, 5, so it would be a bar graph of 5. 80 to 89, 1, 2, 3, 4, 5, 6, 7, 8. And 90 to 99, 1, 2, 3, 4, 5, 6, 7, 8. So what can we determine from looking at that? Well, we can see that the majority of the grades, or the majority of scores, is between the 80s and 90s, 80 to 100, okay? Starting at 80, going up to, we'll just say 99, just to be very accurate, because there wasn't any hundreds, okay? So that would be a way. Now, if you happen to have a lot more data points, like maybe twice as many, you can break up your sets into 2 rows. So instead of having all the 20s in one single row, we can say, well, let's do 21 to 20, 20 to 24, and then 25 to 29, and then 30 to 34, and 34 to 39. So again, these are representing what their classes were. So if we were writing what was my class here, my class would have been 20 to 24, and 25 to 29, and so forth. Okay, so that's how that translates back into your frequency table. Other than that, it's the same process. You're just breaking it into smaller groups. Now, there is something called a double-sided stem and leaf. I don't have a image of that, but for advanced or for AP, I will make sure to provide you guys with an example. For regular, I don't think we're going to have any dual-sided stem and leaf problems. Okay. So our next kind of graphical representation of quantitative data is a dot plot. And this basically works out to be the same thing. You're going to be grouping, you're going to identify the numbers. Your number line should represent as closely to possible as what you want to be able to, your data points. And they should be very standardized. So counting by tens, counting by hundreds. If you notice that there's 10 little tick marks between it, just in case there was like a 165 there, okay? If you don't have everything very clearly identified so you can actually tell what every dot spot is, it's not a good dot plot. It's actually very inconsistent. These are often used, but they are often misused. So that just be aware of that. Now, the great thing about them is just as you had with the stem and leaf, you actually can see a frequency table almost being built. Excuse me, a histogram almost being built, because you can see the height of the number of dots. So in this data set, there are 1, 2, 3, 4, 5 actual 120s. There is 165. There are 2 that are 200. So what is the patterns here? Well, it's a dot plot using the systematic blood pressure of 30 patients. So where is the majority? Here we can actually see a kind of a grouping of information. Pattern seems to be like between 120 and 150 is majority of them, and everything outside that seems to be the least expected, almost to the point where 200 seems to be almost what we call an outlier, which is the number that doesn't seem to make any sense in that group at all. So what's our pattern? Um, most of the blood pressure, is between 120 and 150. Okay, and you might even say a percentage if you wanted to, but that's kind of the idea. Okay, a pie graph is one that is very hard to draw. It is much harder to draw, but it's usually used on problems where you're having to analyze the graph, mostly because it's easier to read them. So percentages are of the whole. The circle is divided into sectors representing that percentage. So if we are using the relative frequency when we're talking about that. So you take your total budget for each one of the things, divide it by the grand total for that entire column. That's what E of F is mean. This is their frequency. Basically this is your N. And relative frequency, for purposes of remembering it, is the frequency divided by N. So frequency divided by the total is going to give you a percentage. And then we multiply that percentage times 360 to figure out how much of that circle would actually be in the science and exploration. How much would be the inspector general? And then you basically get as close to an estimate as you can. 250 is more than half of the graph. So you would basically draw your halfway and then go, okay, well, 200 and 180 is half, and then 240 is would be 2/3 of it, so or 3/4. So it's going to be quite a big chunk. Now, what would questions be? They would basically be asking again, which category had the most or highest percentage of occurrence, or which two categories is equivalent to the other, or something like that. Okay, so with these type of problems, I won't ask you to create these, but I will tell you you will be reading them. So you need to make sure you're familiar with the setup. Okay, Pareto is another type of bar graph. For most of the time, we don't really use this, but it is a vertical one. It's a vertical bar graph in which the height of each bar represents the percentage or the frequency. So we have 43% for gasoline, and you would have the frequency going up to that. Bars are positioned in order of decreasing height, which my image is not showing. So that's something that I would like to correct. So you would have your 10, 20, 30, 40, and 50. And oops. So there would be basically gas. And then you would look for what is the next highest number. Well, the next highest number was 24. So that's the next one we'll put on here is diesel fuel. And you're going to put that on. Distilled. And then you'd keep doing that for each one of the numbers. So the next one would be other, and that's 12%. And notice I am coloring it in. Colors are not mandatory, but they sure make it easier to read. So you can basically see the height, you can distinguish the information, kerosene, etc. So you can see it's a diminishing height. That's actually how the graph should look. Okay. Okay, last one, or actually not last one, but the next one is called a scatter plot. This one is the one you're probably the most familiar with from Algebra 1. It involves X's and Y's. The difference is now we have more than one X. This would not, if you notice here at 4, there are two dots. If we were in algebra, we would say that this can't be a function, but what this is showing you is we're actually looking for what's called a residual line, and that's a line that runs through the majority of those X's and gives an estimate. It estimates and predicts. So we can actually find a predicted value. This is called a residual. So this is going to be something that we'll do a lot of at the end of the year, but it is something that is on the AP test definitely tested a lot. And for regular, you'll see this a lot in, you saw it in Algebra 2, and you'll see it in college algebra. So this is definitely something you want to pay attention to. So when we go through all of this, I will show you all of the rules of how to get this information. Okay, the last one, sorry, this is the last one, is a time series chart, excuse me, which basically has your time along the x-axis and then your dots, and you're just basically it's showing what's going on over time. You see these a lot in the stock market. If you go to a stock quote, you can actually see this kind of a chart on there a lot. Okay, so that is all of our charts for 2-2. On the next video for 2-3, we're going to talk about measures of central tendencies, and I'm also going to show you how to do those on on Desmos.com and on the TI Inspires for each specific class.